Find the mass m of the hanging block which will prevent the smaller block slipping over the triangular block. All the surfaces are frictionless and the strings and the pulleys are light as shown in the figure. Let mass m is moving with acceleration A as shown in the figure. With acceleration in downward direction, then the m ducts will move with same same acceleration same acceleration in the right direction, in the rightward direction. Now the free body diagram is drawn here because this is theta, so this will be theta, and this is the mass of a smaller block mg. So it has and there will be a normal force in this direction on the this block due to this block, and so there will be two component n sin theta and n cos theta. Weight of the body, this body will be in this direction mg, and because a string and pulley are light, that is massless, so uh, there will be tension everywhere same. Now FBD of m, that is FBD of this body, tension in the upward direction and weight in the downward direction, and it is moving with acceleration A. So mg minus t equals to ma. This is equation 1. Again, FBD of m dash m system, considering both body as a system, because both body is moving with the same acceleration A in this direction, because it is given that this body is in rest on this block. So FBD of m dash m system is shown here. This is moving with this tension force. So we can write T equals to m dash plus m into A, equation 2. So adding 1 plus 2, mg equals to m dash plus m into A. Hence A equals to m into g divided by m dash plus m, equation 3. Now FBD of m in the frame of mass m dash. In this frame we are drawing the FBD of this body, and mass m dash, that is non-inertial frame, so we have to apply real as well as zero force. Here it is shown normal is in this direction, and because the body is moving, this frame is moving in this direction with acceleration A, so we have to apply a zero force in this direction ma, and weight of the body in this direction. Now with this, with respect to this frame, this is in rest, so we can use like write n psi theta equals to ma and n cos theta equal to mg. So dividing 4 by 5 we get tan theta equal to a by g, or a equals to g tan theta. This is equation 6. Now from 3, a equals to m cap m into g divided by m dash plus m plus cap m. This implies a into m dash plus m plus am equals to mg, or a into m dash m equals to g minus a into m. Hence m equals to a into m dash plus m divided by g minus a. This is question 7. Using 6 in 7, we get m equals to g tan theta m dash plus m divided by g minus g tan theta, or equals to m dash plus m divided by cot theta minus 1, because dividing both upper and lower side with tan theta, so this will be g tan theta. So we'll get m dash plus m, and this will be 1 by tan theta, so we cot theta, and this will be cancelled out to form 1. This is the answer. Next, find the time taken by M1 to strike the pulley. Where M1 equals to 1 kg, M2 equal to 2 kg, and M3 equal to 3 kg. This is pulley M, this is pulley B, this is M1, M2, and M3. And the distance given from the first pulley is x is equal to 2 centimeter. Let the acceleration of M1 be a naught in upward direction. Then acceleration of pulley B will be a naught in downward direction. As here it is shown, we are considering the acceleration of this body with respect to ground, that is it is moving in upward direction with a naught. So this pulley will be moving in downward direction with the acceleration a naught. So FBT of M1 will be T, here it is shown, T in upward direction, M1G into, that is weight in downward direction. I'm moving with x a naught. So we can write T minus M1G equals to M1 into a naught, equation 1. Now FBT of pulley B will be T in upward direction and T dash in the downward direction. This is moving in downward direction with acceleration a naught. So to that 2 into T dash equals to T, equation 2. Let acceleration of M2 is A in upward direction with respect to pulley B. Then acceleration of M3 will be downward with respect to B. If we consider the acceleration of M2, that is this mass M2, if we are seeing the acceleration of this body and this body from B, and it is A in upward direction, and it is A in the down, for this in the downward direction. Since frame of B is a non-inertial frame, so we have to apply the pseudo force to solve the problem. So FBT of M2 will be real plus pseudo force. F3 will be M2 into A naught, because this frame is this whole moving, this whole system is moving with A naught. So we have applied pseudo force on this body. So T dash Fp and Fp, the pseudo force in upward direction, M2G in the downward direction. So we can write equation sigma Fy by M into Ay, or M2 into A naught plus T dash minus M2 into G equal to M2 into A, equation 3. Again FBT of 3, real plus pseudo force again, so M3G in downward direction, T dash in upward direction, and pseudo force in upward direction. M3G minus T dash minus M3 into A naught equals to M3 into A, equation of motion, equation 4. Adding 3 and 4 we get M2 into A naught minus M2 into G plus M3 into G minus M3 into A naught equals to M2 into A plus M3 into A. This implies M2 minus M3 into A naught plus M3 minus M2 into G equals to M2 plus M3 into A. Or M2 minus M3 into A naught equals to M2 plus M3 into A minus M3 minus M2 into G. Or A naught equals to M2 plus M3 into A minus of M3 minus M2 into G divided by M2 minus M3, equation 5. Now from one now from Now from 1 and 2, 2 T dash minus M1 G equal to M1 into A naught. This implies 2 T dash equal to M1 into A naught plus M1 into G, taking this side. Hence T dash equal to M1 into A naught plus M1 into G by 2. Putting this value in equation 3, we get M2 into A naught plus M1 into A naught plus M1 G by 2 minus M2 into G equals to M2 into A. Or 2m2 into a naught plus m1 into a naught plus m1 g minus 2m2 into g equals to 2m2 into a. This imply a naught into 2m2 plus m1 equals to m3 g plus a minus m1 into g. or a naught equal to 2m2 into g plus a minus m1 g divided by 2m2 plus m1, equation 6. From 5 and 6, because we have also find a naught in the 5, and we are also finding the a naught from 6. So equating both equation, 2m2 into g plus a minus m1 g equals 2m2 plus m1 equals to m2 plus m3 into a minus m3 minus m2 into g divided by m2 minus m3. And using all given value, 2 into 2 into g plus a minus 1 into g divided by 2 into t plus 1, 2 plus 3 into a minus 3 minus 2 into g divided by 2 minus 3. This is like 4g plus 4a minus g by 5 equals to 5a minus g divided by minus 1, or minus 4g minus 4a plus g equals to 5a minus 5a, 25a equals to 6g minus 4g equals to 2g. So a equals to 2g by 29, equation 7. Now from equation 6, a not equals to 2 into m2 into g plus a minus m1g divided by 2m2 plus m1. So using this value, finally we get a not equal to 19 by 29g. Again, acceleration of m2 with respect to pulley a m2 p equals to acceleration of m2 with respect to pulley will be acceleration of m2 with respect to ground minus acceleration of pulley with respect to ground. So am2, that is acceleration of m2 with respect to ground, will be equal to acceleration of m2 with respect to pulley plus acceleration of pulley with respect to ground. So putting value a plus minus of a naught equals to a minus a naught, and putting all value we get minus 2g by 20 naught. Negative sign so that am2, that is acceleration of m2 with respect to ground, will be downward. Now m3p, that is acceleration of mass m3 with respect to pulley, acceleration of m3 with respect to ground minus acceleration of pulley with respect to ground, or this implies acceleration of m3 with respect to ground equals to acceleration of m3 with respect to pulley plus acceleration of pulley with respect to ground equals to minus by a minus of a naught equals to minus by a plus a naught. Putting all value we get minus 21 by 20. Now the negative sign indicates that m3 is moving in downward direction with respect to ground. So this is the solution. Next, a block is kept on the floor of an elevator at rest. The elevator stands start descending with an acceleration of 12 meters per second square. Find the distance of the block during the first 2 seconds after the start. Take g equal to 10 meters per second square. Since here a is greater than g, so the block and elevator will move separately. Now block will move downward with the acceleration g. Hence displacement of block 1 half gt square 1 by 2 into 10 into 0.2 ka whole square 5 into 0.0, so equal to 0.2. Find the time taken by block to reach at A. Now FBD of block, this direction equals to x-axis and this as y-axis. Mg sin theta normal and mg cos theta, because mg in this direction, this is the theta. So mg sin theta equal to ma hence a equal to g sin theta is hence बराबर s बराबर ut plus half at square, u is 0 here, so l बराबर half g sin theta into t square. Here it is clear that the block, this whole system is moving with velocity v, constant velocity. So this is not a case of non-inertial frame, it is also an inertial frame. So we are using directly this formula mg sin theta equal to because this body will move due to the this component of mass weight, and if it is the acceleration in this direction, so we are writing mass into a force बराबर mass into acceleration. So T will be equal to under root GL by T equals to under root 2L by G sin theta, answer.